Hello guys, today some of my friends have requested me to explain what OSPF is, Open Source Path First. I couldn't assist them individually, so I made this tutorial. Uh, I don't know if it's worthy or not. Uh, Open Source Path First, uh, it is one of the examples of uh, link state protocol. First, what we need, this is OSPF lab. Actually, this is OSPF lab. I will come to this later. Let me first explain what OSPF is. OSPF is one of the protocols of which falls under link state protocol. First, we need to understand is what is link and what is state. Link is in fact connection between nodes, connection between the networks, network devices. That's called link. And what's the state? State of connection is always of two types. That is, one is uh, connected and one is not connected. It means link state protocol means it is the protocol which is concerned with the connectivity the connectivity of uh, of network devices like routers, switches, etc. And this is uh, uh, if you just this is actually autonomous system. Let me give you the example of autonomous system. The system, computer system in library, in a university, in a corporation, in a corporate environment, that is autonomous system. And this is autonomous system. In fact, this lab, you're looking at the moment, is a lab autonomous system. And what we are going to do is uh, uh, we are going to do OSPF configuration in this OSPF lab, in this autonomous system. If you just ignore this circle, first this rectangle and these three circles, if you just ignore this, then first ignore this. The autonomous system is divided into area. In this case, there are four different areas. Uh, how the concept of area emerged, how this autonomous system is divided into one, two, three, and four OSPF areas. Why? What we need to understand first is each and every router, they have their own database. They have their own, like, topology depicting the shortest depicting the path from destination source to destination. Uh, in link state protocol, the network devices, network device network device, it collects the information of its neighbor devices and advertises the state of those devices. Suppose in this case, this router will collect the information. This router will collect the information of these three routers, and it advertises to other routers, to all other routers. If it's not divided into four different areas, this router will collect the information of neighbor routers 1, 2, 3, these routers, and it will advertise all routers in this autonomous area. Similarly, this router also similarly all these routers will collect the information of its neighbor devices, and it will advertise. It will broadcast. It will advertises the state of those devices to all the routers in this autonomous area. Autonomous area. What happens then? If then how the concept of area emerged then? If an autonomous system is not divided into separate areas, then the link state database, the database of this router that poses the state of neighbor device is called link state database. The size of database becomes much more bigger if autonomous system is not divided into different areas. Why? Because this router should contain the information of all other network devices. If it's not divided, I mean, if this autonomous system is not divided into areas, different areas. So the autonomous system is divided into areas. What happens if the autonomous system is divided into areas? Then the the a router, suppose in this case this router will, if the autonomous system is divided into different areas, then the router will will a router will uh, collect the information of its neighbor device, and it advertises only to those devices which are within the area the advertising router is. I mean this router will in this case, this router will advertises the information only to these three routers. In this case, this will advertises only to these three routers. So size of the size of uh, link state database, the size of database of this router will become much more smaller. Why? Because it should contain only the information of these three routers. I mean, of the routers which are only within the area. Is in this case, this router will not contain the information of these routers. Why? Because it doesn't lie. This do not lie in this area. Well, that's in this case, the autonomous system. This whole system is called autonomous system, and this is divided into four different areas: 1, 2, 3, and 4. One is OSPF, and it is named as OSPF 120. This is OSPF 0. This is OSPF 99, and this is OSPF 123. It means the autonomous system is divided into four different areas. Now, what we need to understand here is, then first of all, let's understand what area border router is. The router which connects two areas is called area border router. In this case, this is the area border router. In short, what we can say is the inter area router is called area border router. It means the router which lies between two different areas is called area border router. Then in this case, this is area border router, this is area border router, this is area border router. And what's the responsibility of area border router then? The area border router will collect the information of routers of its area, and it advertises to the other areas. In this case, this router will collect the information of this area and advertises to this area, and the other way also applies. Like this router will collect the information of this area and advertises to this area, and same thing applies in these two routers. This router will collect the information of this area and advertises to this area, and collects the information of this area, OSPF 99, uh, it advertises it to OSPF 123. Now, what we need to do is here, but in this case, in this case, what I want to explain is this this OSPF 99. This area is different from these three areas. This area, and this area. Why? Because it is multi-axis type of network. It is multi-axis type. What is multi-axis type? This is multi-layer switch, and this switch is accessed by this multiple routers. That's why it's multi-axis network, OSPF network, multi-axis OSPF network. I'll come to this later. And this is OSPF 0. OSPF 0 is always core network. It's backbone area. It consists the central routing information. It consists of central routing information. As it contains the central routing information, all other areas need to be directly connected with this core network, this area, this router. Why? Because it contains central routing information. The packets needs to be delivered to the correct destination. But in this case, this area 120 OSPF 120 is directly connected with this with core network. This area is directly connected with this core network. Core network is also called as backbone area or area 0. Okay, these two are connected. These two areas are directly connected, directly and physically connected with area 0. But this area is not connected. So how does this area get central routing information then? It's not directly connected with this area. In order to in order to acquire in order to get central routing information from area 0 by this area, in this case area 123, the virtual link should be created between these two area border routers. It means the virtual link will be created between these two area border routers. It's not directly connected, it's not physically connected. It will be connected by configuring. That's why it's called virtual network. It means the network will connect the discontiguous areas, like this these three are contiguous, but this is not contiguous, this is discontiguous. That's why in order to connect this discontiguous area with area 0, the virtual link should be created. Sometimes what happens is the area 0 can also be divided into multiple areas. In that case also, virtual link should be created. Suppose if this OSPF area 0 is divided into two different area 0, suppose the other area 0 is here, which is discontiguous, then the virtual link should be created between these. Here should be one area border route, and here should be connected. The virtual link should be created between two area 0 as well. It means the virtual link will help to create a connection between discontiguous areas and discontiguous area zeros. Well, I think I now let you know, and the 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 area through which the virtual link passes is called transit area. This is transit area and this is transit storage. I mean, the area which lies between area 0 and discontiguous area is called transit area. In this case, OSPF 99 is transit area, which is of multi-axis type, which is of type multi-axis network. In this case, this is multi-axis network because this device switch is accessed by these three routers. In this case, the question will arise: then which router will collect the information and advertises to other areas? Then what happens is there will be the election. A router will be elected among these three routers in this case, and the elected router is called the designated router. In this case, this is designated router. This designated router will collect the information of other routers in this area and advertises to other areas. Sometimes designated router fails. Then backup designated router will carry out the responsibility of designated router. Backup designated router this. And how we elect the designated router then? The router in the OSPF area containing containing the highest IP address is called IP address will be designated router. Yeah, this autonomous system is not configured yet. That's why we can't see the IP address here. IP address is not allocated to the interfaces. That's why we can't see IP addresses here. Once we configure all these routers and allocate IP addresses, then we can easily find out which one is designated router, which router has highest IP address. So we can easily elect the designated router. Now I have finished explaining the scenario of this OSPF lab. This lab, I'm using packet tracer, Cisco packet tracer, as as an emulator. You can use it other tools as well, like GNS3. GNS3 is more robust, but in this case, I'm using packet tracer. In order to configure, you need to have the concept of subnetting as well. You need to have the concept of subnetting. Uh, uh, few years back, there was a classful IP addressing system, where the IP addresses are categorized into like class A IP address, class B IP address, class C IP address, class D, and class E IP addresses. Class D and E were reserved, but but the classful IP addresses was not that effective. The world is running out of IP addresses because of more and more addition of network devices. It means in classful IP address scheme, the IP addresses are not utilized properly. It means the IP addresses uh, used to get wasted. So in order to overcome that problem, the classless interdomain routing, CIDR, is introduced. Classless interdomain router. In that case, and the IP addresses are not categorized into different classes. Let me have a glass of water, and I'll be back.